Okay, well, welcome back for video number 3. I'll be doing a quick mesh analysis problem to show you how to approach a mesh analysis question. So I came up with this 2 seconds ago. I don't actually know the real answer, but let's figure it out. Find VO using mesh analysis. I originally wrote nodal and then realized this is easier to solve with mesh. So when the question tells you which method to use on an exam or an assignment, you should use the method you're told. So we have this nice circuit here, and we're going to draw the meshes, which are those small little loops. So how many meshes do I have in this circuit? I'll have one here, another one here, and one around the bottom here. And I'm going to label these little I1, little I2, little I3. And what are we looking for? We're looking for VO. I put it it's given by the question, but we're looking for this middle node. What's the voltage? We're going to solve for that at the end. But it asks us to use mesh analysis, so before I even worry about finding the output voltage, I should be looking for the mesh currents. So for each of the meshes, we're going to write a KVL, so Kirchhoff's voltage law, for like a loop. So for I1, we'll go around the loop starting in the bottom right corner. That's just how I do my problems. I'm going to loop around. So first I come through this 8 ohm resistor. I'll write 8. I'm in loop I1, so I'll write I1. What is this 8 ohm resistor shared with? So you have I1 on one side, and we have I3 on the other, coming the opposite direction. I1 minus I3. Continuing around the loop, I come across 2 ohms, so I write 2. I'm going through loop I1, I write I1. What is it shared with? Nothing, because it's on the outside. Then I come across a voltage source. These are nice and easy for mesh analysis. I'm coming in to the negative side, so I'll do minus 5, the value of it. And the last part of my loop is this 2 ohm resistor. So plus 2, 2, I1. And what is it shared with? I2. And this all equals 0, KVL. Now I'm going to simplify this, but I want to write it in terms of, let's just call it like AI1 plus BI2 plus CI3 equals D. Just a general form of the simplified equations we're going to look for. That way we can easier organize it to solve it with a matrix. So, gathering the like terms, we have, if I factor out I1, 8 plus 2 plus 2 I1. I2, I only have 2 times minus 1, so minus 2 I2, whereas I3 is only here, negative 8. And that all equals the 5, I have to remember and move that over, equals 5. Simplifying with math, 12 I1 minus 2 I2 minus 8 I3 equals 5. I'm going to highlight this because this is my first equation. Let's use blue. So that's for loop 1. Now let's look at loop I2. Actually, I'll write over here just to save some paper. So for loop I2, I'm going to start at the bottom right corner just because that's how I do my problems. I'm going to go around the loop. I first come across 8 ohm resistor. So I write 8. I'm looking at loop I2 because that's the current going through. I2, what is it shared with? I3 minus I3. Continuing around the loop, next to resistor. It's 2. I'm looking at loop I2, so I can write I2. Minus, it's shared with I1. Come around the top, I come across a 4 ohm resistor that has currents I2 through it. And there's nothing on the other side because it's on the outside of the circuit. I come in the negative side of a 9-volt voltage source, minus 9. This all equals 0. Simplifying it, as I've done up in this other part of the question, to this form, I'll factor out the coefficients. So if I have I1, it's only here, this is minus 2. Minus 2, I1. Now, I2 has 3 terms, 4, 2, and 8. It's 2 plus 8, I2. I3 is minus 8. And now there's this constant from the voltage source. That goes to the other side. Simplifying this, minus 2, I1, plus 14, I2, minus 8, I3, equals 9. And that's my second equation. Now I should look at my loop I3, the last loop. So for I3, actually I'll put that in orange just to be consistent. I3. Starting bottom right corner, there's nothing along this bottom part. I come in the negative side of 12, minus 12. Then I come across an 8 ohm resistor, plus 8. I'm looking at loop I3, so it's I3. What is this resistor shared with? I1. Coming across, I have another 8 ohm resistor, so I'll put 8. I3 minus I2. And lastly, continuing around the loop, I come around this 4 ohm resistor. This will be I3 minus 0. And this will equal 0. Simplifying this, I have negative 8I1 minus 8I2 plus 8 plus 8 plus 4 I3 equals 12. Taking it one step more, plus 8, 16 is 20. I3 equals 12. There we go. We have 3 meshes in our circuit up here, and now we have our 3 equations. So I don't feel like solving this using substitution. I'm just going to plug it into my calculator. So I'm going to arrange it in a matrix. So I'll have a 3 by 3 main area with whatever's on the other side there. I'll just write I1, I2. You put all the I coefficients for I1 in the first column, coefficients for I2 in the second, coefficients for I3 in the third. So my first equation is 12 up here. 12 minus 2 minus 8, 5. My other equation, negative 2, 14, negative 8, 9. Minus 8, minus 8, 20, 12. Now I'm going to solve this using my calculator, which I do not have at my table here. Let me just get it from my bag. So, I have this model calculator to solve it for a matrix. I have a menu, alpha A. I go for simulate equation or simultaneous equations, enter in 1. How many number of unknowns do I have? I have 3. So under 3. And now this calculator adds an X, Y, Z, an equal sign. It doesn't really matter. I just enter the coefficients as I have them in my matrix. So 12 minus 2 minus 8, 5 minus 2, 14 minus 8, 9 minus 8 minus 8, 20, and 12. I still have to be careful about the negative signs. I sometimes miss them. So I press enter, and it'll start giving me numbers. Now I can write these as fractions. So from this, I'll get I1, so this gives me the first one, equals 222 over 85. My calculator gives me fractions. I prefer to keep my answers in fractions so I don't get rounding errors. I2 is equal to 431 over 170. I3 is equal to 226 over 85. So this is nice and all, but I found my mesh currents, but for my problem, I actually want VO. So what I can do is that I know the voltage here. At this node, because if I take the bottom part, yeah, that should be ground. So if that's 0, I go up 12 volts. This part here is at 12 volts. So that's nice, but I want what's in the middle. I want this part, VO. Well, I know every current in my circuit now because I solved it using mesh analysis. And I have a voltage, I have a resistor, I have a current through the resistor looking for this voltage. If I redraw this part of the circuit, plus or minus 12, I omitted the units. I figured that you should know what it is. If I have 8, now I'm just going to leave out the other parts of the circuit. Don't care about that part. And then I have here plus or minus VO, and that goes to ground. And that goes to ground. Well, I can also connect them like that. Well, I can draw a KVL here. What do I mean? If I write a KVL for this loop, starting at the bottom corner, I'll go negative 12. Let me use my black pen. Minus 12 plus V equals IR. If I take that, let's call it VR. Negative 12 plus that voltage across the resistor, and I enter in the positive side of VO equals 0. Rearranging, VO equals 12 minus VR. Now what is VR? Through my resistor here, I have my mesh currents. So I'll have I1, I'll have I3. So just breaking out the resistor, I gave it arbitrarily the plus and minus VR. I could have picked the other direction, that's fine. But through this resistor, there's currents I3 and currents I1. Now, if from Ohm's law, we know VR will equal to the current through the resistor, IR. I should label that too. So the current through the wire is IR. These currents are my mesh currents times R. And it's an 8 ohm resistor, but what is IR? IR is equal to, it's going in this direction, because for passive sign convention, through a resistor, the current will flow into the positive side of the voltage. So IR will be in the same direction, positive I3, because it matches the direction I want, minus I1, because I1 is going in the opposite direction, times R. And I'll sub it all in at the end. Going back to my equation over here, VO is equal to 12 minus I3 minus I1 R, where R will be 8. VO equals 12 minus 8, I3, 226 over 85, minus 222 over 85, equals, punching into my calculator. If you're using this calculator, switch back to the main mode, menu 1. I'm going 12 minus 8226 over 85 minus 222 over 85 equals, for the final solution, I'll round it to two digits. 11.62, this is a voltage, volts. To make it all nice and tidy for whoever's marking it, I'll write the final answer, therefore VO equals 11.62 volts, and I'll put that in a nice box. Now, I don't actually know if that's the real answer. I don't have a solution for this question. If it's not, let me know in the comments, but the basic process is all here, and that's the more important part, because odds are somewhere along the way you'll miss a negative sign. Generally, that should be okay. Whoever's marking it will see that, and you'll get part marks. But that's how you solve a simple mesh analysis question. Next up, I think I'll solve a nodal analysis question. So stay tuned.